DAWGS are a smoother, more efficient version of your word graphs that we used earlier, which is trees and tries. And what we want to do is we want to take a look at DAWGS, and I think our take with DAWGS is to get a sense of how are DAWGS different from tries and trees. The same dictionary, if we implement that as a dog, how is that different? So I think the first thing that you can notice is that in this specific case, we've actually been able to reduce the number of branches. We've also been able to reduce the number of nodes in the try, right? So if you compare, if you go back to about 17 nodes, right? You have about 17 nodes in total to represent these 10 words. And if you go at the dog, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So rather than 17, you now have about 11 nodes. So are less nodes better or worse? Less storage, more faster search because there's less distance to travel, more efficient search. These are all possible variations that you can walk through and go through. Does that make sense? So when you move from tries to DAWGS to the same dictionary, you'll find that DAWGS are a more efficient storage. And there's the original paper, which is the fastest Scrabble program in the West, and then there are Medium articles and lecture notes and video lectures, and they all talk about the fact that the DAWG implementation is a more efficient implementation simply because it requires a lesser number of nodes. From a search perspective though, right, this takes a little getting used to, because now when you think in terms of the right words or how to look for words or how to search for words, right? So how would search work? A, C, E, and D for aced, and ACER for acer. And then for car, for example, CARE and then CARED. So okay, there we go. So CARED and then CAR just for car, right? And then BEER for beer, right? I think from our perspective, when you look at the first two, it's possible that you may not get a full sense of how sophisticated or how complex this implementation looks like. And in this case, we're looking at C, D, and E. So now cars, which is CARS, and then done, and then dog, and then EAR, eats. So double circle implies that this is the end of word. This is a complete word. So for example, DO is a valid word. DON is not, but DONE is a valid word. Similarly, CA is not a valid word, but CAT and CAR are both valid words. And then EA is not a valid word, but EAT and EAER are both valid words, and so are EATS. I have this dictionary, right? And this dictionary has a little bit more number of words. So I sort of tweaked the dictionary rather than using just the 10 limited set that we have. I'm still going to stay with A, B, C. I'm not going to D and E, but I've added sort of a bit more of depth on the C side and on the B side, right? And if I look at the implementation of this, this is what a dog looks like for this dictionary. Or find, just like we did last time, what is the highest scoring word on this list? Words that you need are there either in your tiles or in your anchors. They're available. You just have to, you could start with the longest, that's one possible path, but what else would you start off with, right? So if you think in terms of C and B, what's the score of B and what's the score of C? So I think Fatma's heuristic is an interesting heuristic. She says, when you look at edges that have higher scoring words, right? So for example, C and A, between A and R, they're the same, so you can possibly explore both. Then R again has RAE, so they're the same again, and then this is, but then this has a P, this edge has a P, right? So between the C and the P, this is useful. And then this has a Y, so this is also useful. So now you've got two more. So now you're saying CAR. So if I trace this path, right, CAREENED, this does not have these two. So I want to get onto this specific path, and this specific path is C, R, E, E, P, and then Y. So creepy is one possible candidate. Is creepy a higher scoring word compared to careened? What do you think? Creepier is a higher scoring word? Are you sure, Junaid? You've got anchors and you've got tiles. So that's your anchors. These are essentially starting points or prefixes or suffixes on the board, and then you've got your letter tiles, right? The question is, how do I sort of combine the two together? Yeah, you want you don't want the shortest scores, you want the best score, the biggest score, the highest possible score, right? So your objective is to say that if I start with anchors from a search perspective, both prefix or suffix, how would that process work? And right now what we've done is we only looked at one part of the problem, right? We only looked at the dictionary representation. How is that dictionary representation work in terms of a model? So we looked at two. We looked at trees and tries, which was the first part of this class, and then now we're looking at DAWGS, which is more efficient representation of the two. Now that we've gotten the dictionary representation sorted out, we also have to think in terms of how does the word anchor combination work. So you can't solve this, you can't answer this question unless and until you go back to the board. So you actually have to go back to the board. And I think what I want to do next is take a look at, so I've got a couple of variations here. I'm going to take you to the board first and then come back here to see what we can do here. Two pieces. When I said at the start of this class, I said when you play with Scrabble at the Grandmaster level and it beats you at every single iteration and it beats you with a very, very large margin, it seems that there is magical intelligence at work, but it's not. It's essentially mechanical processing and speed. And then some part of that processing is what we call pre-processing. So if you think in terms of the assignments or your assessments, right? If you think in terms of your assessment, typical assessment is what? We gave you a model. So we gave you a word generation model. We asked you to build it. Then what did you do? Then we gave you a list of questions. We said, use these questions to calibrate your answers to see whether your models are working correctly. We did the same thing with board eval. We gave you 2 slides, some write-up, couple of questions, said build the model, calibrate the model, look at the answers, and then take the assessment. So anything that you do before the quiz is essentially pre-processing. And the reason why you do the pre-processing is because you will not have time during the actual assessment to build the model. Now take that same logic and apply that logic to Scrabble. There is stuff, for example, this building of the try and the dog, should you be doing this as you start the game? Should you do this at every single move that comes through? Or should you just do this upfront right at the start of the game? So when you're loading the game, just build the try and dog at that point in time. Or even better, if you got some kind of a mechanism or a storage technique that allows you to save, download and store, just generate it once, then store it, and then every time you play the game or start the game or initiate the game or initialize the game, just reload it. That's one part. But then there's also pre-processing that happens while you're waiting for your opponent to make his or her move. And the paper refers to this pre-processing. So one pre-processing is, generation of the dogs or the tries, depending on what you want to use. But there's a second pre-processing, and that deals with how do you sequence it. So now if you think in terms of basic sequencing, if I ask yourself, if you read the paper, and most of you said, we've taken a look at, some of you haven't taken a look at, you haven't sort of only sent the video, think of this as an examination question, a quiz question, right? Quiz question is, if you think in terms of sequencing, there is word generation, there is board placement, there is word validation, there is validation of the placement, and there is scoring, collective scoring of the word that you've placed across all possible combinations. As a quiz question, if I say, we've investigated 4 weeks on dissecting and decoding and breaking down the Scrabble AI engine into subcomponents, and we've identified these 1, 2, 3, 4, 5 components. What's the correct choice? What's the correct sequence? So remember this. This is 1, 2, 3, 4, 5. So word, board. So word generation, placement, word validation, placement validation, and scoring. That's 1, 2, 3, 4, 5. To your mind, what is the right sequencing? In what order should this work? So A is basically, okay, do the word generation, then do the placement, then do the validation, then do the, what was it? Sorry, go back. 1, 2, 3, 4, 5. So word generation, word placement, word validation, placement validation, and scoring collect, right? 1, 2, 3, 4, 5. What is the right sequence? So you got 3 choices, A, B, C, and D. What is the right sequence? Take a minute. Take a minute and just write down the right sequence. And then think of this as a proof of life test, right? Or a proof of life check. I want to see whether, what we've shared and what we've explained, made sense to you, and are you paying attention or not? I have 94 participants and I only have 30 answers, right? So the rest of you who are not there, I'll use this as a attendance quiz. If you think in terms of the process that we followed, if you read the paper and you followed the instruction, you followed the discussion, what are we saying? So if I go back to the sequencing that we've looked at, you have a set of anchors and tiles, and you're trying to say, okay, I've got a starting anchor, and let's say I use that as a prefix, and let's say that starting anchor is C, and I've got a list of tiles, and I say, okay, I have 2 possible options, A and R, so I'm going to walk through both options right now. So these are the 2 options I'm walking on. I'm walking here and walking here, right? So this is one option and this is one option, and I have both of them. And then I have E as do I have an E either in my tile, then I have an E, and then I have another E, so I have 2 E's, and then I have a P, and then I have a Y. And as long as I have these tiles with me, I have a valid word. And then when I put this valid one in, right, so what have I done? I've generated the word CREEPY. I've also validated it while in the process of generating it. And because I'm looking at the anchors and tiles combination, the correct answer is that as far as the word generation, word validation, and placement is concerned, all 3 of them happen at once. And that is the magic of efficiency. If you think in terms of Excel, what do you do in Excel? First, you do the word generation. Then you limit it down to valid words. So then you make sure that you've done the sampling without replacement, and you've done the right combinations, and remove the duplicates, remove the extra values. So then you get sort of shorter list. Then you take that list and you validate it. Then you have that validated list of words, and then you place it. But in this specific instance, you start off with an anchor, you use the anchor, you said C is my prefix. Well, I'm looking for suffixes. For suffixes, I'm trying to see, do they have the relevant tiles? As long as you have the relevant tiles, you can use that as a logic. How long would it take you to answer that question if you hadn't done the pre-processing, which is essentially read the paper or thought about this as a question? Again, this discussion, the lecture that we're having today is essentially focused and based on the paper Fastest Scrabble Program in the West. And while some of you have seen the video, if you have to read the paper to really understand the points and the logic and the design that the author emphasizes, right? So let's think in terms of the structure, right? The structure, one of the elements of design that the paper talks about is pre-processing. It talks about pre-processing from a word generation stage. So now you've got a 15 by 15 Scrabble board, and on that 15 by 15 Scrabble board, you've got a list of anchors, and the list of anchors are basically all anchors that relate to a valid starting points. And think of these anchors. So let's take this example of a move. In this specific instance, M, O, V, E are all possible what? If you're looking from this perspective, at this point in time, here, M is a prefix, and you're looking for suffixes that start from this point in time, right? E is a prefix, and you're looking for suffixes that start from this point in time. At this stage, here, at this point, using this as an anchor, M is what? Is M a suffix or a prefix? This point in time, M is a prefix. But if you're looking at this set of anchors, right? M is, so here, this M is a prefix. Pre comes before. This point in time, Yeah, this place, right? This point in time, M is what? M is a suffix, it comes after. Whatever word you pick and identify would need to end at M. Here, whatever word, here at this point in time, whatever word you identify will have to start with an M. So you're starting at the start of the tree and you say, okay, I want to see all words that begin with the letter M. You're looking at M as a prefix. When looking at all words that end with the letter M, you're looking at M as a suffix. You look at other examples that sort of illustrate the same principle. So now if you take at M, what you want to do is you want to go through each anchor. You're not going to look at all the anchors together. You want to go one by one in sequence. So there's a paper, a Medium article that walks through the implementation of the fastest Scrabble program using Python, and he's gotten a very detailed walkthrough, or at least a very visual walkthrough that you can use. And in that paper, he gives an example of quote. So if you look at quote as an example, right, he says that from a pre-processing perspective, what you want to do is that you want to take, let's take this example, O, right? What are all the possible valid letters which would make a valid combination with the word O as a suffix? So BO, DO, GO, LO, JO, MO, these are all valid combinations. NO, even OO, and then PO, and then SO, and then TO, and then W and Y, right? And then what about all the valid letters that would use O as a prefix? So that's OD, OE, OF, OH, OI, OK, OM, ON, right? And then compare this with T. So now let's take a look at T. So T is the right prefix for T are A, E, I, S, and U. And then A, E, I, O, and U. Then using this as a combination, what does he do? Yes, you're only looking at two-letter words. You're only looking at two-letter words. And I'll give you an example a little later. I'll clarify this. Using this combination, then what do? Then we say, okay, using that combination, we can actually create a sequence of word which says best. So best is actually a horizontal placement, and it allows us to, now if you look at C, for example, here, C, the only valid combination is an H, right? C here also, the only valid combination is an H. The only word that sort of can come when you look at two-letter combinations of C, it's an H. N, E, X, T, right? Now in this specific instance, if you look at T, if you're looking at four-letter words, you would say that X is also a valid combo with T. But do we see X as a valid combo? Is X in this list? It's not. So you're only looking at two-letter words. So when you say BO, DO, GO, HO, these are all valid two-letter words. And then again, OD, OE, OF, OH, OI, OK, OM, ON, OP, these are all valid two-letter words in the Scrabble dictionary. How many anchors do you have? With move, how many anchors do you have? 4 on top, 4 at the bottom, that's 8, and then 2 on the side. So about 10 anchors, right? What you want to do, you want to go through each anchor one by one. And again, in the paper, in the fastest Scrabble program in the world, there are about 2 or 3 sequencing, sequence of steps given that it used to iterate. So the idea is that you start with the first anchor, which is what they do here. Start with the first anchor and evaluate the right possible combinations, then do the next one, then do the next one, then one. So as you walk through all the possible combinations, you're also evaluating how the words that you've identified, work together and combine together. It's a search problem, right? You create a list of all possible valid words and all possible valid combinations, then the combinations of the combinations together, and then see and find out what's the best possible solution that gives you the highest possible score at that specific point in time as you go through. So for example, in this specific instance, right, let me go back to the board. Yeah, there you go. So here, let's take a look at this board, right? So now, for example, if I'm looking, let's say I have this set. These are my words, right? O-L-I-K-P-A-G. And you're looking at anchors. And now how many anchors do you have? On the board, how many anchors do you have? Count the number of anchors on the board. Count the number of valid anchors on the board, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Consensus appears to be about 24. But is it 24? So let me see. So 20, 21, 22, 23, 24, 25. About 25 anchors. About 25 possible anchors, right? It's possible that, because you just done this on the fly, we may have missed something. But let's say say about 25 anchors. So now how would the process work? How would you sort of evaluate? So think in terms of the paper, which is the fastest Scrabble program. Think in terms of tries and DAWGS. Think in terms of what we've discussed. Now think in terms of first identifying the right combination of words, and then doing what? Then placing those words. And given what I just said, the generation, the placement, and the validation happens at the same time. And we've done this class, we've done this specific example, this specific board, we've done multiple times in the class, right? You should be very familiar with this. So we know that the highest possible word here, what's the highest possible word? What's the highest scoring word here? In this specific, for this specific board and this specific selection? If you assume that AWOL is a valid word, then O and L, if you add O and L, so AWO, would AWO be a valid word? When you think in terms of pre-processing, when the AI, don't think of it as a player, as you playing a player. If you think in terms of the AI has done the pre-processing, which basically runs for A, for Q, for U, and then for W and I and T, right? So for O as the suffix, it's figured out what's the right possible combo. In this specific instance, the right possible combo is not a two-letter word. It's not looking at A only, it's looking at A and W, right? So, and then when it's on the other side, it's not looking at W, it's looking at A, W, and some other combination, right? So, what are the right possible words that go as a suffix, as a prefix on this side, and as a suffix on this side? And then again, as a suffix on this side, and as a prefix on this side. So you do that list. Then you would make that list here. Then you would rank that list. And then you'd score that list. And then you'd figure out what the right placement is. The question is not what is the highest scoring word. The question is, take this grid, take this sheet, then work through the algorithm. Work through the fastest Scrabble program in the world. Work through the algorithm and figure out how the algo would work using this specific board. And it's only when you've done that would you understand what needs to be done and how to move forward with that progress. Let's take this word. Let's take AW, right? So now when you think in terms of valid combinations from AW, how many more cells do you have here and here? For N and O, right? 14 and 15. You already know what's the cell coordinate for this. This is 114 and 115. So you know for a fact that you're only going to look for two-letter words. So for AW, you're going to look for a three-letter word for AW and a four-letter word for AW. That's it. And on this side, right, where you're on this front, right, on this front, you're standing at about 11. So you can actually look all the way till here to see, how many words can you use. But now, how many tiles do you have? You only have 7 tiles. So it doesn't make sense to go all the way back to 11 because you don't have 11 letters. What would you do? You just say, okay, I've got these two and I use this as what? I use this as my suffix. Now, do I have any combination going up to 7 letters that can serve as a prefix for this word? And you'd start it one by one. So you first do it for a suffix for a 1 letter, then a suffix for a 2 letter, then a suffix for a 3 letter, then a 4 letter, then a 5 letter. You'd run this in sequence. And then similarly here, if you look at neither, right? If you look at neither, use neither as a prefix. From a suffix perspective, you're only going to explore a maximum of a suffix that goes as high as maybe 3 letters. But you'd first do a 1-letter suffix, then a 2-letter suffix, then a 3-letter suffix. And then you'd list and rank all of them and then say, okay, of all the possible choices across all the possible anchors, all the possible prefixes and suffixes, what is the best possible move? That's what the AI does. But the reason why it appears that so fast is 2 things. One, it's done the pre-processing. For each of these squares, for each of these values, it has a valid possible combination. It says, okay, these are the valid possible words. Then it looks at the tiles and the anchors. It says, do I have the right combination of these words? And then it searches the dog or the tree, depending on the implementation, to find out whether the right possible combination and the right possible words represent valid words on your tree or dog. No. So Ali, you're not going to get rid of word gen validation and placement. You will do word gen validation and placement, but we'll use the try or the dog for that purpose. You still have to follow that process, but you'll follow that process in a more efficient fashion. You're not getting rid of it, right? You still have to do it, but you're going to do it in a more scientific, more efficient, more elegant, more effective fashion. Now, quick wrap up. I think if you think in terms of story selection, right? If you think in terms of the start of this course, when we first spoke about anchors, when we first spoke about word generation, we wrote a story. And what was the story? A story was that, if I want to place word generation, I start with an anchor, I rank the anchor, I look at special squares, I look at special tiles, I look at distances, directions, and range. And then, I take the anchors and the tiles, I mix the words, I generate the word, I place the word, then I, validate the word against the word bank, then I place the words on the board, then I filter the word, place the word and score, right? This was the anchor story, right? This anchor story for us, from here to here was the original story. That's where we started off from. And what we've now done is that the story is still similar. The story hasn't changed, but the implementation of the story has changed. And the implementation has changed how? It's changed by a consideration of efficiency. And for us, efficiency is 2 things. For us specifically in this specific case, efficiency is space. The amount of storage do we need in terms of both memory and time? How long does it take us to search through that storage to find out what the right valid word is, and how many times do we have to perform that first? So how is this efficient? You have to, when you think in terms of whether something is efficient or not, you have to compare data, work, order, and grading, right? So storage, processing, sequencing, and efficiency. And for us, the original algo was generate all possible tiles, then validate them against the dictionary, then evaluate all the anchors, then evaluate all possible combinations, then place them, then score them, right? But now that's not what we're doing. Now what we're saying is, think in terms of that model and think in terms of this model. In this model, we sort of short-circuited the process by doing the generation and validation piece and placement piece in a single step. But in that single step, we're still doing all 3, but we're doing them in a much faster fashion. There is a more efficient placement of the dogs. So this is trees and tries. This was trees and tries. This is dogs. Dogs are more efficient because they have a smaller limited number of nodes. And then what's the difference between these 2? So how do dogs compare with trees and tries? Are there, from an implementation perspective, from a storage perspective, from a space perspective, from a search perspective, which one is more efficient? And if they're efficient, why are they efficient? Don't take my word for it. Look it up and find out why are dogs more efficient than trees and tries. I think the last part of our discussion is what should you expect at the weekend assessment. Now, you've gone through 2 assessments, week 1 and then week 2, and this will be your 3rd assessment. What is the scope of the assessment? So the scope of the assessment is everything that's been assigned in terms of readings and videos. You have to take a look at that. And the Scrabble paper, the world fastest Scrabble program, is part of the assessment. Hopefully today's lecture and today's walkthrough, which is essentially based on the same paper, the approaches and the things and the elements that we've covered all come from the same paper, should help you sort of take a better pass at that paper. But then within and outside of the paper, the things that you have to think about are word generation, word placement, anchors, the fastest Scrabble program, tries and dogs, and then actors, roles, and behaviors from the lecture in between from week 3. How should you prepare for it? You have to figure out, it's not enough for you to read it. You also have to understand it. And then you have to think about applications across all topics, cross applications, thinking questions, thought experiments. I think once you've done this, I think you'd be in a much better position to take the assessment. So that's all I had for today. I'm happy to take questions.